Okay, so we're going to talk about what's called the Law of Sines today. Okay, the Law of Sines. Now, the Law of Sines is used for certain types of triangles, mainly non-right triangles. You can use it with right triangles, but it really doesn't make sense to do that because it's easier to use SOHCAHTOA. Okay. So we're talking about angle, angle, side, angle, side, angle, side, side, angle. These are the three triangles that we would use the law of sine to solve. And what we mean by solve is what? When we say solve a triangle. When we say solve a triangle, we mean find all the missing parts. Find all three angles and find all three sides, okay? So the law of sine looks like this. Sine A over A equals sine B over B, which equals sine C over C. And basically what that means is that I can set up any proportion using any two of these ratios. So I could do sine A over A equals sine B over B, or I could do sine A over A equals sine C over C. It doesn't matter. All three of them are equivalent. So what does that actually mean? Because it's kind of confusing looking. So if I have a triangle, I'll call it ABC. Doesn't matter where I put angle A, B, or C. However, it is important to keep the corresponding sides with each other. So here's angle A. We represent the angles with uppercase letters, and we represent the side with lowercase. So angle A points to side A. Right? Angle B points to side B, and angle C points to side C. Okay. Okay, so let's look at an example. And again, I don't memorize everything, okay? I do have the basic law of sine memorized, but I don't memorize which triangles it works with because it's kind of common sense once you learn how to use this formula, okay? So let's look at an example. Let's say that angle C is 102.7 degrees. I'm sorry, 0.3 degrees. Sorry about that. And angle B is 28.7 degrees. And we're going to say side B is 27.4 feet. Okay. Let me just pull up my calculator here. So we want to find all of the missing parts. So we need to find angle A, we need to find side A, and we need to find side C. Okay. How would I find angle A? Yeah. So angle A is going to be 180 minus 102.3 minus 28.7. Okay. And what do we get? 49. Good. So angle A is 49 degrees. Okay. Okay, now to find the sides, we have to use the law of sine. So we're going to say, I'm going to use sine B over B because they gave me these two values, right? So I'm definitely going to use the B. And I'm going to look for side C. So this will be equal to sine C over C. Okay, that's the proportion I'm going to use. Okay, so that means we have sine, okay, angle B is 28.7 over side B, which is 27.4. And that's equal to sine of angle C, 102.3 over side C. Okay. So we're going to cross multiply. 27.4 times the sine of 102.3, and that will equal C times the sine of 28.7. So then to solve for C, we're going to divide by sine of 28.7. Okay. Notice that I am not calculating these values yet because I don't want to round early because that will affect my answer. Okay. I'm going to leave them uncalculated until the very end. All right. So we're going to do this on our calculator now. 27.4 times the sine of 102.3. And then we'll divide that by the sine of 28.7. Okay. So 27.4 sine, I need to make sure I'm in degree mode, right? Sine of, I forget what we said, 102.3. Okay. And then we're going to divide that by the sine of 28.7. And we get 55.747. Okay. Now, looking at my triangle, all of my answers are rounded to the 10th place. So I'm going to round my answer to the nearest 10th. So 55.7. Okay. Any questions on that part? Okay. Now we need to find side A. When we do that, we do not want to use this answer because that answer is rounded and it could be wrong if I made a mistake, and that'll mess up side A. So I'm going to use the information they gave me. Anytime possible, use what they give you in your calculations, okay, if at all possible, okay? So once again, we've got sine B over B, right? That's the information they gave me. They gave me angle B and side B. And we're going to set this equal to, now we're trying to find side A. So it'll be equal to sine of A over A. So this is going to give me sine 28.7 over B 27.4, and that will equal to sine 49 over A. Okay, cross multiplying. 27.4 times the sine of 49 equals A times the sine of 28.7. So once again, we're going to divide by sine of 28.7. Okay, and we'll do that on our calculator. Okay, 27.4 times the sine of 49. And we're going to divide that by sine of 28.7. And we get 43.06. And remember, we're going to round it to the nearest tenth. So we get 43.1. Okay. I always just double check to see if my answer makes sense, right? The largest side should be opposite the largest angle, and it is. The smallest side should be opposite the smallest angle, and it is, okay? And then you can kind of just get a rough idea, right? We've got 28.7 degrees, 49, so it's a little less than double, okay? And this is a little less than double, so my answers do make sense, okay? So you can use these proportions in any way, okay? The reason I don't worry about memorizing which triangles it works with is because in order to use this, okay, you look at what we have. In order to use the law of sine, I have to have an angle and its side along with another angle or another side. Okay, I have to have one angle and its corresponding side, and then another angle or another side. When you go to start solving the triangle, if it's something that you can't use a law of sine with, you're going to find you don't have enough information. Okay. Okay, let's look at another example. All right, this time I've got a pole that tilts toward the sun. Okay, so let's draw the sun here. There's my sun. It's so hot that it's all wavy. Okay, so we've got a pole that tilts toward the sun. Okay. And it's tilting at an 8-degree angle from the vertical. 8 degrees from the vertical. Okay, so there's my vertical. Okay, that means this angle right here is 8 degrees. It's going to cast a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole. Okay, the angle of elevation from the tip of the shadow to the top of the pole, so we're talking about this angle right here, is 43 degrees. How tall is the pole? So this is much more applicable than what we did when we went out to measure trees, because we were forcing everything to be right angles, right? And everything is not right angles. In fact, they're usually not, okay? So this is the same type of thing, right? I have an angle, I have a distance from the bottom of the pole. I'm trying to find this value right here, okay? So we'll call this A, B, C, okay? Okay, so I'm going to have to use sine A over A, right? Because I have angle A here, and I'm looking for, instead of calling that X, let me call it A. I'm looking for A. What can I set that equal to? If I use angle B, I need to know side B. Do I know side B? No. If I use angle C, I have to use side C. Do I know side C? Yes. So I'm going to use sine C over C. Okay, so let's see what we have here. We've got sine of 43 over A. A is what I'm trying to solve for. And now I need sine of C. So I don't have angle C. We've got to figure that out. What information do I have that can help me figure that out? Do I know this angle, angle B? Do I? What is it, Emily? 98, yeah. This is, angle B is 98. So now I can find angle C, right? C equals 180 minus 98 minus 43, which comes out to 39 degrees. Okay? You okay? Okay, so now I know angle C is 39 degrees. So I've got sine 39 over C, which we know is 22. Okay, so we're going to cross multiply. 22 sine 43 equals A sine 39. So we've got 22 sine 43 divided by sine 39 equals A. Okay, so let's do that on our calculator. 22 sine 43. Did I do that right? Yes. Divided by sine 39. 23.84. So again, we're going to round based on what they have in the problem. So what are we going to round that to? 24 feet. Okay, and that's the height of our pole. Question? Yep. Say it again? Squiggly, yes. Thank you very much. Approximately. Good job. Good with that? Okay. Let's look at another triangle here. Okay, so this time we've got side A is 22 inches. Right? Side A is 22 inches. Side B is 12 inches. And angle A is 42 degrees. I want to solve this triangle. Now this one is different. In the other two examples, right, in the first example, we had two angles and I was able to find the third angle by subtracting from 180. And the same thing down in this one, although it wasn't as obvious, we had information to get two angles, so I was able to find the third angle. In this example, I don't have information enough to find the third angle, okay? So I have to use my law of sine to do that. So I'm going to do sine A over A equals, now I've got side B, so it's going to be sine B over B, okay? So that's going to give me sine of 42 over 22 equals sine of B over 12. Question, ladies? You got questions? So you understand why I use the A, right? Sine A over A? Well, if I look at the other information I have, this is side B. Since it's side B that I have, I'm going to use the sine B over B. Okay, so we're going to cross multiply. 12 sine 42 equals 22 sine B. So we'll divide by 22. 12 sine 42 divided by 22 equals sine B. Okay, 12 sine 42 divided by 22. So we get 0.36498, right? 0.36498. That's sine B. How do I figure out angle B? Inverse sine, right. So we're going to take the inverse sine of this number. Now, I left the whole number in my calculator, so I'm not going to round it until the end. Okay. So I'm going to do inverse sine of that answer. And what I'm going to do is use the answer function on my calculator instead of retyping the decimals. So we do second, and down here above the negative sign, second answer. Okay, that puts it in there for me. And I get 21.4 degrees. Does everybody understand how to do that on their calculator? Yep, let me do it again. Okay, so what we do, okay, we do the second function, and down here above the little negative sign down on the bottom, it says answer. So if I press that, it gives me whatever that previous answer was. So we're going to do inverse sine and then plug in that answer. And that way I'm not retyping all the numbers and I'm not rounding. Okay? Yes.
How do you insert on the calculator?
See above the delete key? There's an insert. So you press second insert. Okay? Okay. So we have that angle of 21.4 degrees. And then I can easily find the third angle and the third side. Okay? Now, what we have to consider, this is what's called the ambiguous case. Anytime we're finding an angle, we have to consider whether or not there's more than one answer. Okay? Because that triangle could look like this, but it could also, see if I can do this here. Let me see here. Right, here's my 42 degrees, right? Make sure I get this right. I can never draw this. I'm visually challenged. Yeah, it could also be going something like this. It could be doing, whoops. Yeah, it could be doing something like that, okay? So what we have to do is consider whether or not there's another possible angle. So let's just think about our unit circle again, okay? We're talking about sine. So in this particular case, we got 21.4 degrees as our angle, okay? So there's the reference angle. Where else would I have a reference angle of 21.4 degrees when we're talking about sine? Well, it's positive, and sine is positive up here, so it's the top half. So it would be over here. This could be 21.4 degrees. So what we have to do is say, okay, what angle is that actually? Right? 180 minus 21.4. 158.6. So according to my inverse sine, according to my reference angle, another angle that's going to give me an inverse sine equal to 0.36498, right? Let me do this. Let's do the sine, right? The sine of 158.6 is also equal to 0.3648, okay? The sine of 21.4, was it 4? Yeah, okay. So see how I have two angles that are going to give me that result. I have to consider both. So the question is whether or not this is possible as a solution to my triangle. And in this case, the answer is no. Why is it no? Why can't this angle be 158.6? Yeah. Here. Right. It's going to be more than 180 degrees for the triangle. So in this case, this is not going to be a possible solution. But I have to consider it because it might be. There may be more than one triangle that fits these. Yeah.
How can we even apply the unit circle to it? Because it's not like the unit of one.
Yeah. So it's not necessarily applying the unit circle. We're just using the unit circle to help us visualize the reference angle. To help us visualize that there's another angle that's going to give us a sine equal to this value. Okay. So we're not, that's a good question because a unit circle, the one side is always 1. And we're always talking about those right triangles. So it's not, we're not really applying it. We're just using it to help us visualize the angle. Okay. Okay, let me give you an example of one that does have more than one triangle. Okay. So let's look at, okay. So let's see, side A is going to be 12. Side B is 31. Angle A is 20.5. So let's solve this triangle, okay? So the question is, in addition to just that triangle, is there another triangle that fits that? Like maybe a triangle that looks like that, okay? 20.5, 12, 31. Okay. So let's see, we have angle A and side A. We have side B, so we'll do sine B over 31. Oops, over B. Okay. Okay, let's plug everything in. So we have sine of 20.5 over 12 equals sine of B over 31. We're looking for this angle right here. It gives me 31 sine of 20.5 equals 12 sine of B and divide both sides by 12. Okay. So that means I'm taking the inverse sine of 31 times the sine of 20.5 divided by 12. 31 sine 20.5. Okay, we're going to divide that by 12. And then we take the inverse sine of that number. And I get 64.78 degrees. 64.78 degrees. So we're going to round that to 64.8 degrees. Okay? So that means I'm saying that this angle is 64.8 degrees. All right? Now, we're going to use our unit circle to help us. Okay? 64.8 degrees is right here. Where's the other 64.8 degrees that we're dealing with? Over here. Right? So we're going to do 180 minus 64.8. That's going to give me this angle. I'm looking for this angle right here now. Does everybody understand that? Okay, this was my reference angle of 64.8, which means I'm actually looking for that angle right there now. Okay, so we're going to do 180 minus 64.8. Which gives us 115.12. Is that a possible angle? Could this angle be, look at it over here, could it be 115.12? Yeah, because 115.12 plus 20.5 is still less than 180. So it is possible that we have another triangle where we have 115.12 degrees. Mika, you had a question? Okay. So that is possible. That means I have to solve both triangles now, because if this is 64.8 degrees, angle C is going to be different, right? So what's angle C? 180 minus 20.5 minus 64.8. So let's figure out what angle C is. 20.5, 64.8. So angle C is 94.7 degrees. Okay. But in the other triangle, angle C is going to be 180 minus 115.12. 180 minus 115.12 minus 20.5. 44 point, we'll round that to 4. So I have a different angle C, which means side C will be different in each triangle. Okay, so finding side C, we've got sine of 20.5 over 12, sine A over A, equals sine of 94.7 over C. Okay. Okay, so that means I have 12 sine of 94.7 equals C times the sine of 20.5. So C equals 12 sine 94.7 over sine 20.5. Okay, let's see. 12 sine 94.7 divided by sine 20.5. I get 34.2. There's side C. Oh, we're just going to round it to 34, sorry. Okay. And then working on the other triangle, we're looking at sine, let's say angle A, so sine 20.5 over 12 equals, now I'm looking for side C, so sine 44.4 over C. 12 sine 44.4 equals C sine 20.5. So we have 12 sine 44.4 over sine 20.5. So we have to do that calculation. And we get, is that right? That can't be right. 12 sine 44.4. Oh. Here we go, 23.97, or we'll call it 24. Okay, so we have two completely different triangles. Okay, anytime we're solving for the angle, let me restate that. Anytime we have a triangle that only has one angle, we have to consider that it might be two triangles. Okay. One is an acute triangle and one is an obtuse triangle. So if you only start with one angle, we have to consider the fact that we might have two triangles. So this is a case where there were two completely different triangles. We had to solve both of them, twice as much work. And this is a case where we considered a second triangle, but it didn't work because the angle was too big. Okay? So we have to consider that second triangle. Questions? Yes, Jesse.
We're doing like two triangles right now because you aren't like giving us the exact triangle, but on these problems, but we have to do the two triangles.
So you have to decide whether you're doing two triangles. So let me see. If I look at this,
But it would be a possibility that there
yeah, so number 3 and 4, it's possible because you only start with one angle. So when we solve number 3, you're going to have sine A over A equals sine C over C. You're going to be solving for angle C. You have to consider the second angle, okay, the second triangle, all right? Good question. So if you only start with one angle, you have to consider that there might be two triangles, okay? Okay, you can spend the rest of the period doing your worksheet.